Hello everyone, my name is Nikolai Rusnachenko, and within this presentation we cover such topic as text summarization, and in particular devoted to the terms of services with the application of the sentence embedding techniques for enhancing the existing methods. Let me first dive into all the details in the definition of the terms of services. This is a type of document that is established the agreement between two parties, used to be a company and a user. And these are such type of text we tend to encounter it with once we're starting to use the service. We tend to find them as relatively long content of the text and the terms that we're supposed to agree with. And another particular case is when someone wanted to get something out of these documents, especially investigate the beneficial and the harmful parts. And all of these cases represent the scenario when we would be interested to have such systems that aimed on the complexity reduction. And there are many ways on how the complexity of the text could be reduced. And that's dependent on the area we are working with this task. So on a context level, it can be counted as a text simplification. As for the whole document, it can be counted as the text summarization problem. So the latter has two main ways on how it could be accomplished. So it could be performed in the form of extracting the most salient text part or sentences, or composing the summary or essay-alike representation of the text, which is abstractive summarization. The combination of these two approaches, starting from the extractive and followed by abstractive one, is the hybrid-alike way of summarizations. And among all these approaches in terms of summarization, due to recent advances with the transformers, the abstractive summarization becomes a relatively hot topic and interest with the related advances. That basically navigates me to year 2017. The significant improvements in such architecture as encoder-decoder, with the appearance of the self-attention mechanisms that establish the connection between words and emphasizing the most important information in text. But this is something not taken for granted because we're supposed to pay a price of the computation complexity, which is basically depends on the size of the context window. So the longer the content we have, the squared complexity of it we're supposed to expect from that architectures. And that is what becomes a source of further investigations into that area. On this slide, we can see that the architectures with such computation complexity represented in a gray color, while within the recent few years, we tend to have a so-called sparse representation of this attention, so that we can work with longer sentences. However, the even longer text, such as terms of services, represents kind of bottleneck with all these techniques. Is the reason where the such as sentence embedding techniques as the core component for these systems finds their application. So now let's dive in on provide more details on these such embedding techniques by starting with the more common domain and the models representation of text parts, such as word embeddings. So alongside with the other models, such as bag of words or TF-IDF, word embedding is the way of representing every word in the form of the vector, such that we can establish or measure the distance between words and in such way establish their similarity. So this concept is actually mitigated to the whole sentences, so that we have deal with the sentence embeddings. And within this paper and presentation, we propose the classifier that's based on such a component. So this component provides the vectorized representation of sentences to the known embeddings from document datasets. So basically, in our work, we have the input as the terms of services document. We have a data set of the legal documents utilized for training this embedding model, as well as serve with the sources of documents with which to establish connection. And the last one, we have a filter component, which is responsible for keeping the most the most salient sentences out of the terms of services document, which is relevant to the one from the legal document data sets. With the particular threshold, we can set up how many of these sentences we're supposed to keep out of the original terms of services document. So again, this component represents the core part of the further components of the results text summarization systems for terms of services documents. And these are further components as follows. So it's the abstractive summarizer. It's the sentence annotation that are based on the other resource we will discover later on. And finally, it's sentence simplification. It's another pipeline that represents the recognition of the complex words, followed by application of the transformers for masking word prediction problem. Okay, so within this work, we will be aimed on assessing the performance of the variety of summarization techniques, such as abstractive summarizers and the extractive summarizers. And this is something that navigates me to the experiment section, where we first provided details on the resources we adopt within these studies. We use the terms of services don't read data set that represents the most significant amount of collected terms of services, alongside with the annotated cases by experts. Another resources we also utilize are presented on the slide. Here it's worth to mention that TOSDR represent the source of the so-called summaries data set, where we keep 10 documents for which we compose the summaries by relying on the annotated cases by experts. Let's take a look on the setup that we provide for our system. So in terms of the sentence embedding classifier, we utilize the following embedding model presented on the slide, and use first two mentioned resources for the model's fine-tuning. In terms of the text summarization, we consider experiments in three parts, where the first part is we assess the extractive methods, such as sentence embedding classifier, in comparison with the other baselines. We also experiment with the abstractive methods by considering T5 variation of model within three particular scenarios of the provided text. And finally, compared with the other target-oriented models, as well as generalized transformers. So, and let me quickly emphasize the results that we have in these experiments. So basically, for the extractive experiments part, it's possible to see that the proposed system significantly outperforms the other baselines. Following to the abstractive summarization, we can conclude that the application of the sentence encoding and embedding classifier allows us to enhance generalized generative models, text summarization models such as T5 and long T5, even slightly higher than results rather than the application of LexRank for extracting more standard sentences. And finally, in the bottom of the table, we see the comparison with the other systems. So, as a conclusion, it is worth to mention that within this work, we provide details and propose embedding extractive classification module that becomes a core of our system, which finds its significant application both for extracting information from TOS documents, as well as using as a part of general purpose abstractive summarizers. Both of them results in enhanced performance. And finally, we provide this system that is based on this core component in the form of the demo. It can be found on the URL and link on this slide. And finally, thank you for your attention, and that's pretty much out of it.